isn't it working? It's not working. Click this page. There. Okay, so I don't know if I can make the screen any bigger, unfortunately, you guys. So if you can't see this, maybe move up. Okay, so applications of the trig functions. So applications are just word problems. So we're just going to see how these would work into a question that you might encounter in a math or physics problem. What you've done in the last couple of days is if you've worked solving for a missing side, a missing angle, and then solving for triangles, right? Solving for a lot more info. So what happens is you have to be able to use your trig knowledge and the trig ratios if they're embedded in, if the problem's embedded in a paragraph, right, or a story. So we're going to be using the 180 rule, Pythagoras, and the 3 trig ratios. So example 1, Kyle stands 8 feet from the base of a street light. The angle of elevation from the ground to the top of the street light is 75 degrees. What's the height of the street light? Okay, so the advantage you have here is you know it's going to be a trig question. So you know it's going to involve a triangle, right? A right triangle. And I guess we just have to get some things established at the beginning. If they talk about things, structures in our world, like buildings or trees or towers or light posts, unless they say somewhere in the question that it's abnormal and it's slanted or leaning, like the Leaning Tower of Pisa might be leaning, every building and tree and street light is assumed to be standing at a 90-degree angle to the ground. Okay? So if it says you've got a street light, well, a street lights are embedded in our concrete like this, right? This is the ground, right? Whoops, this would be the ground. Here's the light, right? So just to establish that the ground and the light meet at 90 degrees. Okay, Kyle is standing 8 feet from the base. The word base means what? Yeah, at the bottom, right? The word basement comes from base. So if he's standing 8 feet away from the base of the street light, this is the light. He's standing, I mean, you could have drawn Kyle on either side, but this is where Kyle is, right? He's standing 8 feet away. And then I also know that gives me this distance, right? This must be 8 feet. The angle of elevation from the ground to the top of the streetlight is 75 degrees. All right, can you see the triangle forming? You can see the triangle, right? Here, this has got to be the third side. So here's our first new term today. You'll see this a lot in the word problems. Angles of elevation. Obviously, it's an angle measure. And this is from angles of elevation. Angle of elevation is measured or formed from the ground and then looking upward. Okay, so this angle of elevation is coming from Kyle, right? An angle of elevation is up from a person or an animal looking up. So if Kyle is standing on the ground looking at the lamppost, if he wants to look at the top of the lamppost or top of the building, okay, watch my eyes or watch my chin even. What happens, right? It goes through a movement, right? So whatever movement that is, so his eyes were looking straight ahead to look up at the top of the streetlight, he has to look up. So that movement, that's the angle created, angle of elevation. Just remember, angles of elevation are always from the ground up or from the flat surface where you're standing, wherever you're standing up. So this would be the angle of elevation. Agreed? From the ground upwards. So that angle of elevation, that's where theta is. That's the 75 degrees. What is the height of the street lamp? Well, that's my unknown. So we usually call unknown sides x. So that's where the triangle develops. Can you figure out how tall the length or the height of x? What do you think?
You have to use the,
You're going to use one of the, are you going to use Pythagoras?
no,
No. I agree. Why aren't you going to use Pythagoras?
because you don't have all the links.
Yeah, you need two sides. So I have to use one of the trig ratios, sine, cos, or tan. Which trig ratio will I use?
Oh, you got the angle.
Yeah. Let's see. Sine is the op over height, right? Adjacent over height. And op over adjacent. Okay, so tan is, you say tan?
Yeah.
Let's see, because I have, this is my angle measure, so I'm looking for opposite and I have adjacent, right? So I agree, I think it's tan for sure. So according to the angle, we've got op over adjacent. So that is tan. I'll just do my work at the side. So I know that tan is op over height, or sorry, op over adjacent. So tan of, I do know theta, 75 degrees.
You forget how you figure out that it was tan again.
Tanis, do you feel like explaining?
Yeah. So if you look from the degree, so the 75, you look
Okay.
across because that's what we're trying to find the x, which is the opposite.
Yeah.
And then the
Yeah.
number we have is the adjacent.
Because this clearly is the height, right?
Oh, yeah.
So keep going, Tanis.
So we don't need the hypotenuse because that is
Yeah.
not an equation whatsoever.
Yeah, okay, I get it.
If you think of it that way too, that's a good way to think of it. By default, you don't have the height. So any equation with height in it is out of bounds, right?
Yeah,
Thanks,
Sure.
Tanis.
Pretty much you just have to take out the one equation that you don't need. And
That's a
then
good way to do it. I've never done it that way before. Maybe I'll change my way of explaining it. That's a good way of doing it. Okay, so X is on the top. What math do I need to do? To figure out what X is, I've got two numbers. What's the math operator that I do? If X is on the top.
8 times 10
Yeah.
75.
8 times tan, 75. And that gives me, make sure you're in degree mode. And that gives me 29.86 feet. So that's how tall the light is. While you guys are working on that for a minute, I'm going to show you, this is a slightly different interface, right, from what I usually use. So this is what I'm going to be using next week and in the following weeks when you guys aren't at school. If you watch this during real time, which I'm going to try and broadcast the same time every day, your class time, there's going to be an option for you, and I'll show you what this looks like, that you can chat and you can ask questions with me. Like, so you can say hi. You can ask me questions during class, right? And then I can respond during class time, like if you have questions. So I'll have a live chat open. If you don't happen to watch it during class time, You can obviously send me email questions later on, or you can kind of follow if other students chat, maybe they'll ask the question that you wanted to ask. So anyway, that we're going to try and see how that works. But every day I'm going to try and record from 1 to 2, same way as I always do, right? Okay, let's do example 2. A conveyor belt rises 1.2 meters over a horizontal distance of 6 meters. Determine the angle of inclination. Okay, so that's kind of like a factory would use. I think it would look like a big kind of wheelchair ramp, right? I think it's like they put heavy packages on the bottom and then the conveyor belt moves it up to the top of a factory floor or something like that. So a conveyor belt rises 1.2 meters. So I guess it rises a total of 1.2 meters. And the horizontal distance it covers is 6 meters. Now remember, this is the horizontal distance, right? This is the angled diagonal. This would be the horizontal distance. This is the horizontal distance. Of 6 meters. Determine the angle of inclination. So again, not to confuse you, but it means the same as angle of elevation. Now, why don't we use the same words if we mean the same thing? Well, just to get you familiar with two phrases that mean the same thing, because sometimes you'll go into a math textbook or on a math site and they'll talk about the angle of inclination. Some websites use angle of elevation, just to expose you to the two words that mean the same thing. So I'm going to give you a sec. I want you to put the theta where you think the theta should go. We're trying to solve for the angle of elevation. Show me where the theta symbol is.
At the bottom.
Yeah, you got two angles, right? It's the one at the bottom. All right, so what trig ratio are we going to use this time? What do you think?
Would be tan again.
Yeah, boring. It's tan again. But again, we're not using hype at all. We can use Tanis's method. So we're using op and adjacent. So it's a tan question. So tan of my unknown angle equals 1.2 over 6. Now, I don't want tan of theta. I actually want to solve for theta. So I have to cancel tan and then do my division. And we get 11.31 degrees, right? Or 11 degrees, I suppose. That's a very low angle, right? It's a very small angle. 90 degrees is straight up and down. So 11 degrees would be very shallow. All these shocks. 11 degrees would be something like this, right? I'd probably do would you agree? Like if this is 90 degrees, half of 90, so I guess like this kind of halfway up, halfway 90, half of 90 would be, this would be about a 45 degree angle, I guess. So 11 is going to be really skinny, right? Does that make sense in this question, Cliff? You've had
No, because sometimes I think of it differently. That's almost a whole 180. Shouldn't it be more?
180 is from here to here.
Yeah, I know that. But I mean, like, shouldn't it be more? Like, I mean, that's
No,
that one with the less angle
this
is-
little piece is all we're measuring.
I know, but shouldn't it be higher, like closer to 180, like more
No.
like one?
Because if this is
69?
90, that's 90. So this would be 45. Half of 45 is like what, 22? And then half of 22 is 11. It's a really teeny tiny angle. What would a
I'm thinking of the
wheelchair,
graphs.
what would a wheelchair ramp be? What angle would a wheelchair ramp have to be?
About 11.
You think? I don't think
Or
it's
maybe
11.
less than that, maybe
I actually
5?
think it's like 5 or 6.
Yeah.
Because can you see why wheelchair ramps would have to be very shallow, very small angles? Because you have to be able to get up a wheelchair ramp, especially if it's really slick or slippery. So a conveyor belt is a little steeper than a wheelchair. And that makes sense to me. Those boxes are chugging along on some kind of a wheel system. There's no way it could go up steep hill. So that makes sense. Okay, last example. Maybe I'm going to see if you could set the triangle up anyway. The angle of depression from the top of a viewing tower, like I guess a park ranger tower or something, to an animal on the ground is 30 degrees. The height of the tower is 25 meters. How far is the animal from the base of the tower? Okay. I would have let you do this one on your own, but there's a new phrase in here, angle of depression, which is similar to angle of elevation, right? The words are. So let's just draw a big park ranger tower, right? Like those towers that they have in parks to watch for forest fires and animals that are in distress. Okay, the height of the tower is 25 meters, so we know that for sure. Towers are built, again, 90 degrees to the ground. The only structure I could think of right now that's not 90 degrees is that Leaning Tower of Pisa in Italy, right? That's tilting. Every other building is built 90 degrees. Okay, the height of the tower is 25 meters. How far, so this is where the park ranger's sitting, right? He's sitting watching for animals. So let's say there's an animal on the ground here, right? This is where the animal is. How far is the animal from the base of the tower? So we're looking for a side length again, right? You've got your two sides of the triangle, right? So let's just draw your triangle. Now it says, the angle of depression from the top of the tower to the animal on the ground is 30 degrees. This is tricky. Angles of depression lie outside the triangle. So this is the tricky part. If I told you, depression means down, right? So if an angle of elevation is an angle formed by it's basically an angle formed by your eyesight. So if you're looking just straight ahead, like most people do if they're standing out in the street, but I have to look up to the top of the Golden Boy or the top of a skyscraper, my eyes are looking up, agreed? If I'm standing on a tall building, let's say I'm standing on top of the legislature and I want to see someone down on Broadway, I have to look down. So that's what an angle of depression is. It's a looking down. So if you think about it, this forest ranger is sitting in the tower. Okay, they're sitting right here. They're looking, so they're basically sitting on some floor on the tower, and this is sort of this simulates the level, the ground level of the tower up there. If they're looking downward, this is the angle of depression. And the angle of depression is 30 degrees, okay? There's two ways I'm going to explain things to you. Like the forest ranger has to be standing on a floor, right? Well, I mean, it doesn't look like it, but he's standing on a floor. They're standing on a floor here. So if I kind of extended that floor, it would be another straight line, right? This would be 90 degrees as well. Would you agree? These two angle measures will be 90 degrees, but I'll explain it
Well, how do you
another
know
way.
that?
Because I'm assuming that the floor is built like parallel to
Level with the
yeah,
ground?
a level.
So
But
if it's
let
30
me
degrees-
do something else for you, Cliff. If I extended this line, the ground goes on forever and ever, right?
Yeah.
Okay. The ground goes on forever and ever. The skyline goes on forever and ever. There's a principle in geometry that if I have two lines that go on forever and ever side by side, and I take a diagonal line and slash it through, okay, these two angles are equal to each other. So basically, your angle of depression equals your angle of elevation. Okay?
Well, how come we just didn't put the 30 degrees on the inside in the first place?
Because that's not what an angle of depression is by definition. But what I'm telling you is when you read the angle of depression in your text, like in the story, you can just say, oh, okay, well, that's the angle of elevation, put it on the ground. However, it wouldn't make sense to me it wouldn't make sense at all if I said the park ranger was sitting at the top of the tower and the angle of elevation was whatever, because angle of elevations are taken from the ground up, right? He's not on the ground. He or she's up in their tower.
Okay.
The other way I can prove it to you is
So that wouldn't be 30 degrees on the inside of the top
no,
part, eh?
what I was trying to say to you, these two guys also have to make
So it'd be 60 degrees.
right. That's right. These two guys make a 90 degrees. So this would be 60. And the other way you could do it is if you use your 180 rule, 60 and 90 make 150. You need 30 more to make your, right? So you could do it that way too.
Find the
Yeah.
angle of elevation.
Yeah. So you could find your elevation the long way or just say, oh yeah, the angle of depression is outside the triangle. If I bring it inside, it becomes the angle of, the angle of depression is outside. If I bring it inside, it just becomes the angle of elevation. Okay. So now what are we trying to find? We know this side. We don't know this side. I'm going to give you a minute.
So you'd have to use cos. Right?
I think it's tan again, isn't it?
Oh yeah, it's Jason and all.
Yikes.
Yeah,
We're going to have to change these examples up so we use something other than tan. So this is my angle that I'm using. It's going to be op over adjacent. However, it is a question that involves division, right? Because the x is on the bottom. So x equals 25 divided by tan 30. Okay, so we did the word problems. I'll give you a bit of time to work on assignment 6. Tomorrow, I will start talking about the law of sines. And I might post some assignments from time to time on the blog just for extra practice. And if you want, you could submit them. If you want to submit some for marks or you just want to get some extra